Our fifth type of factoring is called sum of cubes. So I have two numbers. In the rule, it's written a cubed plus b cubed because they're being added together. When you do these problems, you're going to use a formula. And the formula will always start the same. So I'm going to have quantity a and b together. And then a squared, ab, b squared. The formula always follows a rule. So these two signs are always going to be the same. So for this formula, it will be addition. These two signs will always be opposites. So for this type, it will be subtraction. And the last sign will always be positive. When you do these problems, you want it to be written in the exact same form as the formula. So you want it to be something cubed plus something cubed. So the first step is to rewrite. This first section is good, but I need to fix this second term. So I need to know the cube root of 27, and the cube root of 27 is 3. So I can actually rewrite this as x cubed plus 3 cubed. Once it's rewritten like this, then you can see x is a, 3 is b, and now you're just going to use that information to plug it into your formula. So I would have a plus b, so x plus 3, and then a squared, so that's x squared, minus, and then I have a times b, so x times 3, plus b squared, so plus 3 squared. Now obviously some of this isn't written well, like this part here, and we know what 3 squared is, so we would want to simplify that. So I would have x plus 3, x squared, minus, we typically write coefficients in front of variables, so this is better written as 3x, and then 3 squared is actually 9. So for example 2, we're going to do the exact same thing. So first thing I want to do is I want to rewrite this b term to be written as a number cubed. So I need to know what the cube root of 64 is, and the cube root of 64 is 4. So first step, rewrite as z to the third plus 4 to the third. Then I can see that z is a and 4 is b, and I can use that to plug it into my formula. So it would be z plus 4, z squared minus z times 4 plus 4 squared. Then again, I want to rewrite, so I have z plus 4, z squared minus 4 times z plus 16. Same thing on the third example. First step, rewrite this as a number cubed. The cube root of 125 is 5. So this is really y cubed plus 5 cubed. That means that y is a, 5 is b, and when I plug in, I have a plus b, a squared minus a times b plus b squared. Rewrite and simplify, so y plus 5, y squared minus 5y plus 25. If at this point you feel like you can do everything at once and go straight to this step, that's completely fine. So we'll try that on the next one. So for example 4, first thing I want to do, I want to rewrite this as a number cubed. The cube root of 27 is 3. I can rewrite this as 3 cubed plus t cubed. In this problem, 3 is actually a this time, and t is b. And so when I plug that into my formula, I get 3 plus t a squared. So this time I have 3 squared. I know 3 squared is 9, so I'm just going to write 9 right away. Minus 3 times t plus t squared. The sixth type of factoring is called difference of cubes, which is exactly like what we were doing before, except this time now I have a cubed minus b cubed. The formula is the exact same, so I have a and then b, a squared, ab, b squared. Same idea. These two signs are going to be the same. So this time I start off with subtraction. These two will be different. So it will be addition. The last sign's always positive. So it's addition. Just like before, I want to rewrite so that it's written as x cubed minus a number cubed. The cube root of 1 is 1. So this is really x cubed minus 1 cubed. As you see, x is a, 1 is b. I take that information and plug it into my formula. So I have x minus 1, x squared plus x times 1 plus 1 squared. Again, I'm going to have to rewrite some things. So I have x minus 1, x squared. We typically write the coefficient in front of the number. Since it's 1x, I can really just put plus x. And lastly, 1 squared is 1. For example 2, I need to know the cube root of 64, which is 4. I rewrite this as z cubed minus 4 cubed. I can see that a is z and b is 4. I use that info and plug it into my formula. So z minus 4, z squared. If at this point you're feeling comfortable and you know you're going to have to rearrange, you can go ahead and do that right away. So I know that this really is going to end up being 4z. And lastly, I know I would have 4 squared here, and I know 4 squared is 16. So if you feel like you can start doing those problems all at once, go ahead and do it. On example 3, I'm going to rewrite 8. So I'm going to take cube root of 8, which is 2. So I would rewrite this as 2 cubed minus x cubed. This time 2 is a and x is b. And if I plug that into my formula, I would have 2 minus x, 2 squared, which is 4, plus 2x plus x squared. Our last example looks a little different because we have variables in both terms. I'm going to start the same way by getting the cube root of 216, which is 6. This time when I rewrite, I'm going to rewrite as 6x cubed minus y cubed. And now when I've rewritten it this way, I can see that 6x is a and y is b. And so using my formula, I have a, which is 6x, minus b, which is y. I have 6x squared, so I need to put that in parentheses, plus a times b, so 6xy, plus b squared, which is just y squared. So then last step, I just need to actually square 6x. So 6 squared is 36, x squared is x squared, and then I rewrite.